What is the IP address of your company.com? So that DNS server could somehow be part of this picture and simply answer that question based on the current load. So that's actually nice. Works well in that it does indeed tell the client to then contact that specific IP address. So now let's find fault with this design. Yeah?
Well, computers cache DNS addresses as well as hardware. It's pretty bad about refreshing DNS.
Exactly. So caching, which generally is a good thing in that it can improve performance, it's also a bad thing in that information gets stale. And in this case, the information that might get stale is who is the least busy at this moment in time. And if you have browsers like Chrome and IE caching DNS lookups, which they do, and you have Windows and Mac OS and Linux caching DNS lookups, which they also do, and you have ISPs, DNS servers caching lookups as they do, even if it's for some number of seconds or minutes, the load on these servers is presumably going to be fluctuating quite a bit. And yet if we're answering queries based on this moment in time, and those answers are then reused for some number of seconds or minutes, we might accidentally end up overwhelming server 1 or server 2, and now we might actually have some users experiencing downtime or significant delays, even if server N is completely idle and has resources to spare. So DNS works, it's nice and simple, and in fact we can do it even more simply with DNS. With DNS, we don't really even need a load balancer per se. We could just have the DNS servers use something called round robin, which in computing generally means not using any kind of intelligence to decide what answer to return, but just responding in round robin order. The first time I, the DNS server, am asked what's the IP address of your company.com, I say 1. And then the next time I'm asked, I say 2. And the next time 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So round robin is actually quite nice and appealing because of its simplicity. But what does it suffer from as well? Sorry?
Stale information.
Stale, well, stale, not so much stale, because it's not used taking any information into account. So what's really the downside?
What if the machine goes down and it has a fault?
OK, good. So if a server goes down and you're still spitting out one IP address, 1/nth of your users might reach dead ends. What else?
You could have like asymmetric load per user. So like that first connection could be using a lot of resources. So by the time it gets back, you actually don't want to go back to server 1. You want to skip over to server 2.
Exactly. So if the first user that visits your website is really resource hungry and starts uploading lots of photos, whereas users 2 and 3 just check their wall real fast and then log off, well, you might be sending accidentally a disproportionate amount of load, not number of connections, to the same server. So it doesn't take into account load, but it's super easy, and you don't need to buy or configure special software to do it. You can do it entirely with your ISP's DNS setting. So upsides, downsides. So this load balancer then, we want requests to come in. How else could we do this then? If DNS doesn't seem to be solving this for us very reliably. Yeah, Dan?
It's just the router and it just routes the packets to the computer.
Yeah, so we could actually have the load balancer perform a routing function whereby the requests just come into the load balancer. Everywhere on the internet, the load balancer itself represents the IP address of this website, yourcompany.com. And when the request comes in, it's the load balancer who's closest to servers 1 through n that decides, oh, server 3 is now the quietest. Let me route this request to him. And then using lower level TCP mechanisms or Ethernet mechanisms can send that data from the load balancer directly to the server. The server will then reply to the load balancer most likely, and then the load balancer in turn will respond to the client. So not unlike NAT, network address translation, that your home routers might very well be using. And you can even be fancier than that. The load balancer technically could route the request to server 3, but change the return address to actually be that of the original to do direct return, as it's called, so that you do have to have this funnel of information all coming in. But if the data you're spitting out is large chunks of data, like video files, you don't need to pass all of those video files back through the load balancer. They can go potentially directly back to the user. Yeah, Meryl.
Is the load balancer synchronizing like databases or other resources stored on all these individual servers, or is there some way that it's intelligently saying, okay, the client wants to use something on server 2, so we need to send it to server 2? But how do you aggregate databases and resources across them with this system?
Perfect segue. So short answer is no. The load balancer doesn't do any of that. And for those following along on camera, what does the load balancer not do? It doesn't take into account any kind of shared state that must be shared across these several servers. By shared state, we might mean sessions. So recall from PHP, there's the notion of the session superglobal, in which you can store stateful information, even though HTTP itself is stateless. You might have actual records in a database that need to persist across servers, because again, in the round robin form, if I visit the website now, I might end up on server 1. If I hit reload or click on some link, I might end up on server 2 or 3, just by nature of my DNS lookup expiring, my getting a new IP address back. Or the load balancer itself might be dispatching me here at first, then here, based on changing load. But the problem is, if these web servers aren't all identical, I could get very different views of the world based on chance, based on which server I end up at. And in fact, Facebook has not always gotten this right. Probably all of you at some point have logged in and you see some posts on your news feed, and then if you hit reload, you kind of see different ones, even though they're not newer per se. You just didn't see them before. Hit reload again and you might see another view of the news feed. And this happens from time to time, and as best I can tell, it's actually just a bug, or it's something related to caching, whereby in each request you're getting an answer from a different cache, which is probably not the intended effect, but you can infer from these symptoms what might be going on. So how do we solve this? Ideally, we minimally want sticky sessions, which means that when you've created a session, and sessions generally remember that you have logged in or who has logged in, you'd like this information to be invariant across all of the servers to which you might be routed. So let's take a step back to PHP at least, but the same idea exists in Java and JSPs and Python and Ruby and web context. How are sessions implemented, say in PHP, since that's what we used?
The HTTP headers?
Yeah, so in the HTTP headers is what?
Sorry?
In the HTTP headers is what?
Is the user's login information, and then you can save additional session data in the database.
Okay, good. So, and it's not quite the user's login information per se. When I do go to cs164.net and I log in, and the website thereafter remembers that I've logged in, it's not going to be my username and definitely not my password that's transmitted again and again to remind the server that I've logged in. But what is passed in those headers? A cookie. So some fairly large pseudo-random value that was planted in my browser, in RAM or on disk, by the server, and that server has another copy of that number, probably in a database, or frankly on a lot of servers just in /temp in a file called 1234.txt or some equivalent of that. And then inside of that file or inside of that database is the stuff that I want to be remembered about me, what my username is, what my password is, or at least an encryption thereof, what my phone number, email address, and all of that information is. So that is to say, once you log into a website, your hand, so to speak, gets stamped, and the browser, according to HTTP, is just supposed to remind the server with every HTTP request, I've been here before, I've been here before. And that number informs the server that I've been here before. So there's an obvious security threat here, more on that in a couple of weeks, and that if someone looks at or sniffs wirelessly your hand stamp, they can pretend to be you, and you've probably seen or heard of this. Firesheep is the fun story to tell in that context, or the software to play with. But in more applicable terms here, this cookie is problematic, because where is this cookie information stored typically? Database or file system. If it's stored in the file system, which is the default for PHP, sessions are literally stored in /temp or in /var/lib/php/session or something like that. Well, what's the implication? Well, when I log in and I happen to be on server 1, I'm authenticated on server 1. But as soon as I go to server 2, my browser is still going to present the hand stamp, the big cookie value, but what is server 2 going to do with it? It's nothing, right? It's going to be confused. It's just not going to recognize that number. Or worst case, it's going to be a number that was given to someone else, but probabilistically that's not going to happen. But worst, most likely case, he just doesn't have any session state for me. So what happens to me as the user? I'm prompted to log in again. So I log in again. Another cookie is planted on my computer. Then I get redirected back to the home page. This time the load balancer sends me to server 3. What happens? I'm prompted to log in again, right? So this just does not work very well. So how do we solve this? Storing cookies on disk seems to be bad, at least at first glance.
You can use signed requests.
Signed requests, okay.
So that way, you given the information on a cookie, you look it up against some database database on the server.
Okay, good. So if we introduce into this picture, actually in the signing isn't strictly necessary. If we introduce into the picture just a database, if the problem in this story is that /temp is unique to every machine, or /var, lib, sessions, whatever, is unique to each machine, well then clearly we need to have some kind of storage mechanism that transcends the individual servers. So you can actually use MySQL to store sessions, and every row stores some key value pair, and you can configure this in php.ini, which is the config file for PHP, and it kind of works just out of the box. But now follow the, play devil's advocate here. What's bad about this solution? If we just add a database to the previous picture. Yeah, RJ.
If one database can't handle all the connections, that doesn't work anymore.
Yeah, exactly. If we were solving this problem of horizontal scaling, as it's called, when you duplicate your servers in this sort of linear side-by-side fashion, well, if the problem that we were trying to solve is scalability, and our solution now to the new problem